Hello viewers, in today's lecture we are going to take up some problems related to application of integrals. Here we will find the area bounded by some curves. The first one is find the area bounded by the ellipse. So here the standard equation of the ellipse is given, and if we compare this equation with the standard equation, we get a square is 25 and b square is 16, and from here we get a is 5 and b is 4, right? So here this coordinate is minus 5 comma 0, and this is 5 comma 0. This is minus 5 comma 0, this is 5 comma 0, and here we have 0 comma 4, and this is 0 comma minus 4. We know already these things from our earlier classes, but here just for the sake of revision we are discussing it. So comparing this equation with the standard one, we have these points and we have to find the area bounded by this ellipse, right? So what we will do here, we see that although this figure is a rough sketch of the ellipse, but here these 4 quadrants are identical, and if we find the area of one quadrant, then we can multiply it by 4 and we can get the entire area bounded by this ellipse, right? So we will take this quadrant in the this quadrant, and here we have the strip. This is the elementary strip whose width is dx and height is y, right? So let us take this point as A and this point as B, right? So our required area, that is area bounded by this ellipse, is 4 times the area of this region, right? O, A, B, O. Now this is 4 times area of this quadrant, that is OABO, is given by the definite integral from 0 to 5, and here we have y dx, right? Because we know that the area is given by x equal to a to x equal to b and y dx, right? So now this is 4 times of the integral 0 to 5 y dx. So here we have 0, here we have 5. Now the value of y will be calculated from this expression, and the value is y square by 16 is equal to 1 minus x square over 25, and this can be written as 25 minus x square divided by 25, and y square is 16 by 25 times 25 minus x square, and y can be written as 4 by 5 taking the square root, and this is square root of 25 minus x square, right? Therefore if we substitute this value of y here, we get 4 by 5 times square root of 25 minus x square, and here we have dx, right? Now this can be written as 4 4s are 16, this is 16 by 5, and we integrate it from 0 to 5, square root of 5 square minus x square dx, right? Now here we will make use of an important integral, that is integral of square root of a square minus x square, and this integral is x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a, right? So here we will make use of this integral. So here this is a square and this is x square, right? Now this integral is equal to we have 16 by 5, and then we have x by 2 times 5 square minus x square, square root of 5 square minus x square plus a square, that is 5 square, and it is 25 by 2 times sine inverse x divided by 5, right? And we have the limits from 0 to 5, right? So this is our expression for area. Now we will substitute the limits, and then we will simplify the expression. So here we have 16 by 5, and if we substitute 5 here, we get 5 by 2 times 0, because this is 5 square, and 5 square minus 5 square is 0, plus this is 25 by 2 sine inverse. Here we will substitute 5, so 5 by 5 is 1, and if we substitute the value 0 here, we get 0, and then we have here also 0, right? So here we will have 0 and here we will have 0, so both the terms will become 0. So now we can have 16 by 5, this is 0, this is all 0, and we have 25 by 2 times sine inverse 1, that is pi by 2, right? So viewers, this is if we simplify this, we get 5 5s are, and this is 2 2 4, 2 2s are 4, and 4 4s are 16, so we have 4 5s are 20, this is 20 pi square units, right? So viewers, this is the area enclosed by this ellipse, right, whose equation is x square over 25 plus y square over 16 equal to 1. And here I would like to tell you one important formula, that whenever we have an ellipse of this type, x square over a square plus y square over b square equal to 1, then the area enclosed by this ellipse is pi times a times b, right? So the area enclosed by an ellipse is pi a b, right? So let us verify here. We have the area pi a. What is a? From here we have obtained that the value of a was 5 and the value of b was 4. So this is 5 4s are 20, so this is 20 pi. And see, this area and this area are same. Now viewers, let us take this problem. Find the area of the parabola y square equal to 4ax bounded by the lattice rectum or the line x equal to a. Now we know that this is the parabola y square equal to 4ax, right? And here is the focus, that is S is a comma 0, right? Now we know that the lattice rectum of this parabola passes through this focus, and this is our lattice rectum, right? And let us say this point is L, this is L prime, right? Now we have to find this area. Clear? Okay. Now in order to find this area, let us find the area of this region, right? The area we have to find the area OSLO, the area OSLO, right? So this area OSLO is actually equal to the area OSL prime O, right? Because of symmetry, these two areas are equal. Now what we will do, we will find this area and we'll multiply it by 2. So here let us draw the strip, the elementary strip. Here we have dx and here we have y. So therefore the required area is equal to 2 times the area OSLO. This can be written as 2 times of the area from 0 to a, and here we have y dx. Now the value of y is obtained from this equation. So we have square root of 4ax and here we have dx. Now this is 2 times of 2 square root of a, 0 to a square root of x dx. Now this is 4 times of square root of a, and if we integrate square root of x, we have x 3 by 2, and here also we have 3 by 2, and the limits are from 0 to a. Now this can be written as 4 times square root a. This is 2 by 3, and then we have simply a raised to 3 by 2. If we substitute the value of the limits, here we have a raised to 3 by 2 and the second term will be 0. Then this can be written as 8 square root of a divided by 3 times a raised to 3 by 2, and this is 8 by 3. This is half plus this is a raised to half plus 3 by 2, and we have 8 by 3 a square. So this is the area bounded by the parabola and the lattice rectum, right? So this is 8 by 3 times a square units.